The question says, a piece of hot nickel at 94.1 degrees Celsius is placed into an insulated container containing 223.1 grams of water at 21.2 degrees C, roughly room temperature. If the final temperature of the nickel in water is 33.6 degrees C, what is the mass of the nickel? And then it says the specific heat capacity of nickel is this, and the water is this. Okay, so this is kind of a question where we need to derive a math equation. So I am going to spend a couple minutes to derive that equation for you. The truth of the matter is, once you have the equation derived, you can just plug in the numbers. But note that in this case, the mass of nickel is the variable. Something else could be the variable as well. So in a previous question, we talked about how Q equals m c sub s delta T. So Q of water equals the m of water times the c sub s of water times the delta T of water. And this is also true for nickel. The Q of the nickel equals the mass of the nickel times the c sub s of the nickel times the delta T of the nickel. Now, if you look at this equation here, we know most of these variables. The thing is, we need a way to relate this equation and this equation, and it turns out we have one. Because these are in the same system, we're adding the nickel to the water in the same system, the Q of the water has to be exactly the same magnitude as the Q of the nickel, but in the opposite direction. Okay, so the water is going to gain heat energy from the nickel, the temperature goes up. The nickel is going to lose heat energy to the water, and the temperature goes down. But at the end of the day, they're equal to each other. The amount this increases is equal to the amount this decreases. So now I can rewrite this equation in a different way, which is get rid of these two things, and MH2O times C sub S H2O times delta T of H2O equals this one. If these two things are equal, then these two things are equal. So the mass of the nickel times the C sub S of the nickel times the delta T of the nickel. Now, what we want is our X is the mass of the nickel. So if we divide by C sub S of the nickel and delta T of the nickel, those cancel. And we of course have to divide this side by the same thing, the C sub S of the nickel and the delta T of the nickel. And what we find is this overall equation that the mass of the nickel equals the mass of water times the specific heat capacity of the water times the delta T of the water. It's the same equation here. I'm just writing it backwards, and so it looks a little nicer. And then we get the C sub S of the nickel on the bottom and the delta T of the nickel on the bottom. So this is the equation that we can use. Remember that delta T's are the final temperature minus the initial temperature. So when we do this, the mass of the water is given to us 223.1 grams of water. The specific heat capacity of the water is given to us 4.18 joules per gram degree C for the water. And the change in temperature of the water is the final temperature, 33.6, minus the initial temperature, 21.2, which is 12.4 degrees C. And now as I realize this, I forgot to put the negative sign in. So I need to put the negative there and then put the negative there as well. All right, so I have to take the negative of all of this because Q of water equals the negative Q of the nickel. So I apologize for missing that negative sign earlier. Next, what we need to do is we need to put in the C sub S of the nickel, which is given to us, 0.440 joules per gram degree C, times the change in temperature of the nickel, which is the final temperature, 33.6, minus the initial temperature, 94.1. And when you do that math, you get negative 60.5 degrees C. When you do all this math, you find that the mass of this nickel sample is 434 grams of nickel that was added to this flask.